Good afternoon, everyone. Myself, Dr. Kirti, Assistant Professor, Physiotherapy Department. So, today I'm going to tell you about regulation of respiration. So, respiration is a reflex process, but it can be controlled voluntarily for a short period of 40 seconds. Normally, the quite regular breathing occurs because of two regulatory mechanisms: nervous or neural mechanism, chemical mechanism. So, nervous mechanism that regulates the respiration include respiratory centers and afferent and efferent nerve, which are the respiratory connections. So, basically, the respiratory center are the group of neurons which control rate, rhythm, and force of respiration, which are situated bilaterally in reticular formation of brainstem. So, respiratory centers are two types. First is medullary center, which further constitute dorsal and ventral respiratory group of neuron, and one is pontine center, which include epineuristic and pneumotaxic center. So this is the diagram showing the centers, respiratory centers in the brain and how they are connected to lungs. So first we are having the medullary center. So dorsal respiratory group of neurons are situated in nucleus of tragus solitarius in the upper part of the medulla oblongata. Usually these are collectively called as inspiratory center, and all the neurons of dorsal respiratory group are inspiratory neurons and generate inspiratory RAM by virtue of autorhythmic property. So function is dorsal group of neurons are responsible for basic rhythm of respiration. This is the organization of respiratory center. In this diagram, we can see the dorsal respiratory group and ventral respiratory group here. So here, this is the ventral and this is the dorsal. Now next we are having the ventral respiratory group of neurons. These are present in nucleus ambiguous and nucleus retroambiguous. These are situated in a medulla oblongata and anterior and lateral to nucleus of tragus solitarius. These are collectively called as expiratory center. The ventral respiratory have both inspiratory and expiratory neurons. So the ventral group of neurons are inactive during quiet breathing and become active during forced breathing. Next, we are having the pontine center. First, we are having the epineuristic center, which is situated in reticular formation of loop bones. Its function is to increase the depth of respiration by acting directly on dorsal group neurons. Next is the pneumotaxic center, which is situated in the dorsolateral part of the reticular formation in upper bones. And it is formed by neurons of medial parabrachial and subparabrachial nuclei. Subparabrachial is also known as ventral parabrachial. So function of pneumotaxic center is to control medullary respiratory center, and it acts through epineuristic center. Because of this, inspiration stops and expiration start, and pneumotaxic center influence the switching between inspiration and expiration. So next we are having the connections of respiratory center. So efferent pathways, uh, the nerve fiber from respiratory center leave brainstem and then descend in anterior part of lateral column of spinal cord. Then they terminate on motor neurons in anterior horn cell of cervical thoracic segment of spinal cord. So basically two set of spinal nerves arise: phrenic nerve fibers which supply the diaphragm, intercostal nerve fibers which supply the external intercostal muscle. And the afferent pathways, the respiratory centers receive afferent impulse from chemoreceptors and baroreceptor via branches of glossopharyngeal and vagus nerve, and stretch receptors of lung via vagus nerve. Integration of respiratory center, so role of medullary center. Rhythmic discharge of inspiratory impulses. Dorsal respiratory neuron group is responsible for normal rhythm of respiration, and these neurons maintain normal rhythm of respiration by discharging the impulses rhythmically. Inspiratory ramp, it is the pattern of impulse discharge from dorsal group of neurons, and these are characterized by steady increase in amplitude of action potential. Next, we are having the Herring-Brewer inflation reflex, which is located in muscle portion of wall of bronchi bronchioles. Throughout the lung are stretch receptors that transmit signal through vagi uh, into the dorsal respiratory group of neurons when lungs become overstretched. So this in turn will switch off the respiratory ramp. So basically, if humans not activated until tidal volume increases 3 times more than normal. So this is the diagram showing the HP inflation reflex. One can see, like when we inspire the tidal volume more than 1 liter, then stretching of the airways occur. Then again the inspiratory rate increases, and then there is decreased time for inspiration. So this is the negative feedback servo control system. Thank you.